So let's start. So once again, greetings to everyone. My name is Pratap, and I'm working as a senior structural engineer in MIDAS Research and Development India, working from the India, Middle East, and Africa region. Thank you for attending the today's session, which is actually titled as "Unlocking the Potentials of MIDAS Civil Linux with API Plugins." So basically, MIDAS Civil Linux is a new software solution for the bridges and structures. So if you have any questions during the session, and please feel free to mention into the chat box. So we'll definitely take them either during the session or maybe at the end of this particular session. So starting with the contents for the today's session, first we will be discussed about the MIDAS Civil Linux software. What are the main features we are added into this particular next generation of MIDAS Civil that we'll discuss here. What exactly mean by the API? So many of the they already know about the API functionality, but still, if somebody doesn't have the idea about the API, so what is mean by API and how this particular API will help us in terms of the structural as well as the bridge engineering field. What are the different plugins available? So plugin is again a kind of actually one part of the API. Okay, so there are multiple API functionalities we have added in the software. So in today's session, we'll discuss about the plugins, what are the plugins we have added and how we can build them into the software as well. So that we'll discuss. Further, those who already knows the MIDAS civil software, they may have aware about the different bridge wizards which are there. Okay, but how these particular plugins will differentiate over that particular wizards, that we'll discuss here. And finally, we end up with the software demonstration with summary. Okay. So yeah. So about the MIDAS Civil next, it's basically actually just a one step forward to the MIDAS Civil. So if you check the interface of the MIDAS Civil Linux, we have a completely redesigned the user interface with the existing options are available as per again the user's convenience. So we have added few of the functionalities in terms of the enhancement of the post-processing performance, enabling the analysis results and reports to be generated in the Excel format. If you talk about the result extraction, yes, tabulating the results, let's say for the concurrent forces. So it's almost like we can say the 20 times faster than the usual MIDAS suite software. And in terms of the maybe we can say the visual effects. So yes, now it is in dark mode, and you can see the all the actually the icons are vectorized. You can even customize that one as per the requirement. So few of the modifications that we'll discuss in further slides. So definitely that will actually boost the working of the engineers as well. The main key takeaways from the Civil Linux are we have divided into the four category: automation, user-friendly interface, powerful simulation, and diverse program integration. Why automation? Because as I said, we are actually going to integrate with the we can say actually the design sheets through the Excel sheet, or we can create any geometry or in any inputs using the plugins. Secondly, regarding the interface, yes, again we have actually the crafted this particular interface a little bit more user friendly, and the working environment, or we can say the whatever the accessibility is there, so that is quite easier compared to the old version of MIDAS Civil. Coming to the powerful simulation, so again in terms of the different types of analysis, defining the loads, maybe like instead of the live load using the influencer diagram, we may go with the static position of the vehicle as well using the uh, yes, we can have the additional plugins available for the, let's say, series load generators and all. So that I definitely added a one key plus point in this particular software. And lastly, the integration. So we have now the other external platforms where we can utilize in terms of optimization, in terms of the result extraction, or in terms of the designs. So we can link them with the MIDAS Civil Linux software as well. Okay. So what are these main features? Again, if you talk the user-friendly workspace, powerful simulation as well as for the design, and the automation into the design. Okay. So further, if we talk about this particular user interface, so we again categorized into the three part. First is the intuitive modeling environment. As you can see, a complete actually the picture of this particular Midas window has been changed. So we have the model can be viewed in the different colors. We can uh, show the model into the different multiple models, or the we can say the windows. Second is regarding the wizards. Yes, there are wizards available, the same like as the Midas Civil NX, added the advantage of that particular plugins. And the third one is regarding the automation feature. Now, not only we are working with the frame type of elements, but also we can work with the solid and plate elements, which are a finite element modeling. So that type of geometry is really required for the complex structures. So meshing is one of the benefit here. Coming to the powerful simulation and design. So again, if we talk about that in detail, so moving load as per the design standards. So whenever again we open these wizards or the manual definition of the loads, yes, so that will again generate the quick definition of these particular loads. Okay, here we have talked about the live loads, but again some specialized analysis where we require the time history or the push or analysis. So uh, again, take the example of this. Let's say the time dependent effects, which are required for the heat of hydration analysis, construction stray analysis. That build a main motto of this. Then the seismic analysis, again, whether we are actually interested to perform the time history. So we can generate such type of time history functions, and we can check the accelerations, velocity, and displacements. Different design standards. So again, within a software, if you are interested to perform the design and to get the capacities and stress checks, yes, you can select that particular corresponding code, and we can get a customized design reports into the software. And finally, the functions linked to the analysis results. One of the example is the best idea is to check this particular, let's say the substructure or the foundation check, let's say piers and piles, for which I need to actually check the stress check, interaction ratio, maybe let's say the moment curvature relationship. So for that, we can use the MIDAS general section designer tool. Coming to the design automation, not only actually it's a design automation, but also with the automation linked with the other programming languages as well. Okay, so starting with the grasshopper along with the rhino. So we can actually generate a geometry using this particular the parametric based modeling using the grasshopper. We can link. So in our next upcoming sessions during this particular webinar series, we will be discussing about the Python, grasshopper, Excel VBA, and as well as the we can say the how to actually extract the results in tabular Excel format through the connector. Okay, so that will discuss in detail in that particular upcoming sessions. So just to give an idea, uh, more or less we are also coming with the beam platform as well. So till now we may have uh, heard about the beam platform for the buildings only, but now the Midas is bringing the civil information software, that is a CIM tool, which is a kind of beam platform for the bridges, where we can extract the drawings, quantities, we can say the clash checking reports, and so on for such type of bridge geometries. Further, there is actually generating such type of geometry through the Excel spreadsheets. So you no need to rely on the modeling of the any component through this particular, let's say either manual modeling or the wizards. But yes, we can generate our own a customized Excel for not only geometry part but also till the analysis part. So with the customized Excel through the VBA can be generated here. Okay. Further, we can do the coding. Okay. So that again, everyone is not actually well versed with the coding. So again, we are bringing with options within actually the Excel. We can add the external add-in for extracting the results from the Midas Civil NX to the Excel. So that is required for the customized analysis report. Okay, or even to link that with the design Excel sheet as well, which you already have. So in that case, just you need to download the MIDAS connector into the Excel. Make sure that it should be in Microsoft 360, and through that we can link that particular Excel with that particular MIDAS Linux model. Run the analysis and then just get all the results either in terms of text or in terms of the images and tables. So everything can be actually taken into these particular reports. Plugins. So that we'll discuss in detail in the today's session. So these plugins are nothing but by actually the we can say that actually the coding in terms of the VBA, in terms of the Python, we are come up with some specialized templates apart from the wizards. Through that, not only the geometrical part but also the other functionalities in terms of the loading, in terms of boundary conditions, the loading, result extraction designs. So through that, the plugins are very essential for that particular customized outputs. And not only from the MIDAS, but also the users can create their own customized plugins and they can use themselves. So we will be having this particular marketplace where it will be open for the customer. Okay, so there they can upload their files in terms of the Z format. They can create their own templates and then they can utilize it themselves. Okay, now we will discuss about this particular API based actually the interface. So API, maybe some they may have heard first time. It's basically actually the application programming interface. So application in terms of any other local as well as the languages. Okay, so the main primary communication language is JSON. Now whenever actually we are linking with the other softwares with the MIDAS CV Linux, the JSON format is required here. But again, we are giving you the we can say the customized input parameters as well, those who are new to the software. Okay, so we can actually put the design information to convert these particular languages, either VBA, Python, Java, and so on. So MIDAS API will also give the user in development freedom, and we hope to establish your own company's design process using the MIDAS API. So here, the main developer through this particular JSON API, we will link with the MIDAS CV Linux, and then again, so it can be by any other softwares as well, and then we will actually connect them through the other softwares. We can say the VB and Python. Okay, so at first the MIDAS API only actually could communicate data on the local, but however we have changed this method to the HTTP portal. So it means now you can send the commands using a web server as well. Okay, so wherever you are working with this particular other tools or in the Excel, so we are actually linking with the MIDAS server. Okay, so that particular protocol will be by two ways. One is the MIDAS API key, and second is the base URL, which will connect to the server, and through that you can link your MIDAS Civil Linux software with other programs as well as the Excel form. Okay. Talking about the MIDAS Civil Linux plugins. Now these plugins will reduce the repetitive repeating calculations and data transfer works processes. So here there is one example of this particular plugin. So first example is for this alignment generator. Let's say for a one particular bridge stretch, there may be n number of type of alignments. It can be a straight, then there will be a arc, there will be a clothoid, any other thing, right? Parabolic. So the user can specify, let's say the total length, that alignment length, and then we can specify the number of segments into that. So this alignment, let's say there is a first alignment here, second alignment here, then third alignment is something else. So we can mention that one. Before we actually generate that, you can cross check that one as well using this particular guide diagram. That is actually the main idea, because this is not available in the wizard which are available, right? So that's why we can first judge whether the geometry generated is as per our requirement or not. Second option, if you check this particular plugin, is mainly for the response spectrum generator. Now, again, in earlier the software version, there is only some standard country codes are available for generating the response spectrum functions. But again, you can create your own customized function as well. Just you can create this template, specify the parameters at that particular provisions. For example, if you talk about, let's say, the South Africa code, now which is not available in the current version of MIDAS Civil, right? But anyhow, it is coming into the next version. But let's say if any of this particular version or any of these particular standard codes is not available in the software, they can generate their own this particular plugin. Through that, just they will select the code, specify their parameters as per that code, and then they can first visualize, okay, whether this particular function response spectrum curve is plotting as per the requirement or not. If yes, then once you click on update, it will define that function into the software. Okay. So the MIDAS API is a web-based API, and so it has a lot of expandable possibilities. So the function which is created by, let's say, a one user from a one particular organization, let's say from India, he can utilize the same function which is available in the other regions, let's say in Middle East or in Africa or in any other part of the world. So that's actually the main advantage of this particular web-based API. Second is for the most JSON, that is actually our data format, can be used with the web compatible languages. And Python has a lot of mathematical functions that can be integrated with MIDAS API for several calculations such as geometrical things. That is the example of this particular alignment generator. Proceeding further, so we have the plugins available in the MIDAS. Now, I just listed a few of them here. So I just highlight like series load, group files, alignment generator, response spectrum generator, player peer, tendon profile, and local access. Now, if you talk about this particular the options available in software, we have a marketplace, and then there is actually the user library. Okay, in marketplace, it means it will show the list of all the plugins available in the software. It can be actually accessible for everyone, every MIDAS user. But for the user's choice, yes, wherever any organization, and in that organization, if any user is created a particular customized template for their purpose only, then that will be only available for that particular organization only. So that will not be visible in this particular marketplace. Okay. So that's why, as I said, these are initially they are actually providing from the our side, but there is a full freedom to generate from the end user as well. Okay. So apart from that, we have the breakdown load combination. Uh, there is a space gas importer, initial force controller, 6x6 matrix for the general spring for pile foundation. There's a local axis generator command, convert load combination into HDS format, because this is actually we are generating from as per the user's requirement. Okay, and how to generate that one? So that again we will discuss in detail. So I just show you at the last for our portal where we have explained about these particular functions. And also the temperature gradient stress calculator. So again, as for the eigenstress methodology, how the stresses will be calculated for any standard cross section, or sorry, for the any general cross section. So that will be calculated by the these particular plugins. Okay. Now this is very important thing because the people are having doubt related to this particular plugins and MIDAS wizards. So first I will come with this particular wizard. So this particular MIDAS bridge wizards, they are nothing but if you open this particular structure wizards, we have actually some customized templates available in the software and only for some specific type of bridges only. So let's say cable state bridge wizard. In cable state, max to max, I can generate the 2D structure with the cable arrangement. But what about if it is in dual plane? The pylon or the cables are in the dual plane or in the multiple plane. If there is, let's say, any we can say that there's an unsymmetrical structure is there, so in that case it's now difficult to customize that one in using this particular bridge wizard. And similarly, whenever we are working with one particular wizard, it is actually generating from scratch to end. It means it is generating the model, it is assigning the boundaries, loads, also the construction stages. But what if for that particular model I want to customize the substructure, I want to assign the foundation, let's say open foundation, pile foundation, or I want to apply some load which is not standardized in the software, but I want to define it as a user defined. So definitely in that case, I need to go with some other tools. That is why the MIDAS API plugin will come into the picture. So here, now if I differentiate this, so user can create their own plugins and upload them at the marketplace. These plugins automate the work and save the time for user defined steps, because as I said, for the multiple tasks and which is not possible by this particular the general wizards. So yes, that can be actually done by the plugins. The API plugins can be created for geometrical modeling, boundary conditions, loads, and tendon profiles of any type of bridge. So there is no any limitation for modeling any type of structure through these particular plugins. Okay, initially though we are actually providing some plugins, but yes, you can create your own as well. Now let's go for the software demonstration. So just to give an idea, okay, I will be discussing here about the three types of plugins. Okay, so here I'll first explain about the bridge in curvature. Okay, suppose I want to model this particular superstructure that is in curvature. That curvature can be in anything. As I said, it can be in a different types of alignment for different spans. So I can model that one. Second type of plugin will be for the flared pier. Now that is again the customized one. Okay, so but again, if you want to go for the portal, so we can make the portal by adding that into the other plugin as well. So the for a one file we can use the multiple plugins. Again, that is a one more advantage. Whereas in terms of the wizard, I can use one type of wizard for one particular model only, because wizard will generate the model always from the origin. So I cannot actually generate another type of structure by other wizard within a same file. But here it is not like that. I can specify the start node and start element and from where it has to be started. So that customization can be done using this particular plugins. And then there is another plugin which we are going to use it, that is the group files. Okay, so again we're assuming that with this particular pile cap, whether you want pile cap as a line element or you want directly the piles which is actually connected by the rigid link without considering any stiffness of the pile cap. So that way also we can model using this particular plugins. Okay, so for today's software demonstration, I have taken this particular single span PSC box girder bridge, which is 50-meter in radius and 40-meter in the is the span length. The width of the superstructure is 7.5 meter. That's actually the clear carriageway. I think a total width of the bridge is 8.5 meter. Yes. So let's go for the software now. Okay. So I just opened the MIDAS CLIVIL software. I hope it is visible to everyone. Please confirm whether everyone is able to see the complete window, or they are not able to see the left side or the right side of this particular structure, because some of the attendees, they are asking, they are not able to see the some of the portion of the screen. Okay, I think those who are actually facing difficulty in terms of the screen, maybe you can just try to rejoin the session. Okay, so meanwhile I just explain about the new interface of the software. So just let me open the new project. Okay, so here if we talk about the newly launched interface of the software, so again we have actually the sum of the functions which are shuffled here and there. So wherever we are working looking for the the version of the software, so always we have to check from here, that is from the file menu, that is from the MIDAS Civil NX, that is a 24 2.1 version. Parallel it is going with the MIDAS Civil itself. Okay, right, this is the main menu bar. As you can see, again little bit actually the few of the functions got actually merged in functions. Like we have the project menu, which is like the first added function menu in the ribbon menu. So we have the project information tools, that is actually the available, and the last, now we have added them into the few of the functions. Like instead of tools we have added apps, and from tools this unit system and all we have as well as the bill of material we have added here. This is the view tab. Is again most of the options are same, only we have added few of the options, like now they are vectorized. Okay, structure tab, again the wizards are customized here, so related the different types of construction stages and the composite modules, uh, steel structures and the base structures. Then in the main menu bar, yes, we have actually added like creating the node element together, translating the node element together. So like that, it is easy now rather than searching. So we can have the just the one and tool at a particular location. Properties, again the same thing, like time dependence, they are actually taken in the drop down arrows. Boundary conditions, so again the different types of boundary conditions we have added here. Load is, that is the main thing here. So we have now the drop down list for the loads. So we have static loads, temperature loads, pre-stress load, and these icons you can see they are a little bit enlarged now. So in any of this particular resolution, it is very easy to work with this particular window. Analysis, the different analysis windows in results. Again, yes, these whole results we have now again categorized as per the type of structure. Bridge specialized structures like for cable spread and all. Then there's a related to the time history, related to the heat of addition. So they are vectorized very easily. Pushover design also has actually the added in a drop down. So there was a separate tab earlier for the pre-stressing, but again that pre-stress also added in the same option. Rating, and then finally the apps. So in the application tab, we have the MCT command shell and other menus. Along with that, we have added with this particular main and the most important thing, which is we have launched in the MIDAS Civil Linux, that is the API. So always we need to go to the API setting, and through this particular base URL and the MIDAS API key, we need to actually connect this to the server. Then only your plugins and all will be connected with this particular server. Right. So again, the shortcut toolbars are little bit actually customized here, but again, wherever it is necessary, you can add this particular tools as per your requirement. So you can add any of these functions wherever it is required. There is again a shortcut toolbar, which is again customized, and it can be actually checked from this one. Okay. And now another important thing, there is actually the tree menu related to the tree menu. So if any functions, if you define, so let's say in this particular model, suppose I'm going to import some data, because rather than going with the definitions and all, I will be mainly emphasize on the plugins. So there is actually the search bar is available in this particular tree menu. So I'll show you that one once we start. And similarly, there is another search window for to get an idea about the functionalities which you are working on. If you note, let's say how actually I can do the push for analysis. So yes, you can search the push for, and it will actually take you to our the MIDAS help page. Okay, where it will take you to the, so make sure it will actually come with the list wise, right? And here again we have the command line, so that can be again linked here, and we can see any error or warning which is coming during the analysis. All right, so that's and yes, there's actually the zooming option window is also available, through which we can actually customize your viewing operation. So to start with, I simply actually save this particular file. So just I'll save this file. Okay, to start with, we'll go to the properties, and we'll go to the material properties. So either we can define, now all other options are similar only. So rather than importing it manually, I just take it from my earlier model. Okay. In case if you want to customize any parameter, let's say I want to change it, suppose as per the ASTO code. So I can select here ASTO code, and let's say C70,000, so that I can made it manually. Similarly, let's see here as well ASTO code 6,000. So that's how we can modify easily. Coming to that material and the section, then I'll go to the section property, and here again I will import it from the again the standard model which you already have. Okay. Okay. So here I'm interested to explain you about this particular option. So let's say I want to know about this particular mid section. So only that particular section will be available, and I can easily modify that particular section for me. You don't need to scroll down and check that particular parameter. That's about idea about this particular search command. Yes. Similarly, let's say I want to know the tendon material. So that particular part parameter only will be showing here. Okay. So next is now we'll start with this particular plugins. So we'll go to the apps, and then in the applications we'll go to the plugin option. Okay. So we'll go to the marketplace. Now in this particular plugin, before we start, we have the three functions available for this API related. things. So first is the API setting. So always there will be one base URL where it will actually connect to our MIDAS server, and then this is a MIDAS API key. So always this particular key will keep on changing when it is not connected with the server. Okay, so that you need to connect. So this is the status of this particular connection of the MIDAS CLIVIL Linux. Coming to this particular plugins, so we will be having total 4 options here: marketplace, saved plugins, my work, and bookmark. My works, where the user can upload their created plugins and they can utilize it in the saved plugins. Okay, now in the marketplace, so as I said earlier, we have these particular different plugins available. Okay, and for each of these plugins you can find how this particular plugin will work. You don't need to check for the different stepwise process and all, but yes, we can actually use that one directly. Right, so starting with I will go with this particular first plugin, that is an alignment generator. So this alignment generator, again, it has actually different versions. So I just run it first, and you can find wherever these plugins are available. So you can find the data related to this particular plugin. What are the different options are available, how to input these parameters, and there are some short videos available how these particular plugins work. Okay. Now talking about this particular plugin. Okay, here, sorry. Yeah. So talking about this particular plugin, we will be actually considering a one curved span, which is actually 50-meter in radius and 40-meter in curvature, radius of curvature. So in that, I'll go through this particular alignment and I'll select here, let's say the arc. Now we can select any of this particular alignment. So 40-meter is our span length and radius is 50-meter. Now we'll go to the segments. In segments, so within that particular 40-meter, my first 0.5 meter will be my diaphragm location. Okay, so that is why I have created this many number of sections. So 0.5 meter from both ends are diaphragm section. Next 3 meter will be my support section. Next 3 meter is the tapering, which is from support to mid, and then the within the middle part, which is 27 meter, which is mid section. That is how my geometry will be created here. So total there will be 7 parts. So I'll just, sorry, before actually I was explaining that. Okay, so here I'll just add this particular n number of parts. So total I required 7 parts. Okay, so in alignment I taken 40-meter with 50, right? Now we can just check our base file, and then in the segment now we'll specify like first 0.25-meter distance. Okay, 0.25-meter distance each element length, and there are total 2 elements from both from first end, which is the section provided will be third one, that is the diaphragm. Similarly, I will add next section with the 3-meter each 3 distances, we can say the 3 numbers with the 1-meter length, and the section will be second, that is a support. Similarly, the next length with again the 3 numbers, so it is 1 meter each, 3 numbers with the section ID of 5, that is the taper section, so from support to mid. Next is the length of 1 meter with the 27 numbers, and the section ID will be first because it's a mid section. Then again 1 meter, 3 meter, now the section ID will be 4, that is mid to support. Then first again 1 meter length with the 3 meter, and here it will be second, that is again the support. And last again 0.25 meter distance with the 2 numbers and the support section, which is sorry, diaphragm section, which is 3. So you need to cross check what is the distance, how many number of elements, and what is the section we are assigning. That is nothing but these are our section ID 1 to 10. Once you are able to do that one, just click on create, and then in backend you cross check whether your geometry is being created as per our requirement or not. Okay, so yes, that is generated here. Now you can cancel it and close it. So that's how your curved geometry will be generated, and you can then cross check your geometry. Midsection, this is support, these are the diaphragm head, mid to support, and support to end. Okay. So that's how we are able to generate this particular complete superstructure along with the assignment of the sections using this particular customized plugin. Now I'm going with the next plugin. Okay, that is the substructure. So before that, I want to actually generate the nodes at the soffit level and the nodes at the we can say the bottom of the bearings. Okay, so I without taking the time, I already created the MCT. Okay, so this MCT consists of the new unit system, the nodes which will be created newly at this location. So basically there will be total 8 nodes, and we have created the coordinates for that. Okay, so we have total 4 nodes here, that is the 2 bearings are there on this side and 2 bearings on this side, so total 4 nodes at each end. So that's why I created this MCT for that. There is a one static load case which I have created, that is a construction stage. Okay, you may consider the type as dead load as well. Then we have the material. Maybe you can assign the different material as well as per again requirement. The local axis, the constraints. Uh, okay, so let's say if you don't want to consider the material, so you can even remove that one as well. Okay, local axis for each of this particular node, because this is in curvature. So my nodes will be aligned in that particular uh, the curved alignment. The support conditions, which is again if it is required, so that need to be assigned the support conditions. Elastic links to simulate, let's say, the pot PTF behavior. So what is actually the pinned, or we can say the fixed bearing, transverse guided, longitudinal guided, and the free bearing. Then there's a sections which are required for the piers, or let's say the columns, column top, column bottom, and pile cap and pile, and rigid links which are connecting at a different location, and the sulfate load. Okay, so that's how I added. So just copying this particular data, and then I'll paste from the applications and the MCT command shell. Okay. So just to check this particular model, so we have all the types of elements generated. Then these are again the materials which are assigned, sections, boundary conditions. So here the supports are assigned here, but again I'm not interested to do that, so I'm just deleting that one. There's a total 4 elastic links which are assigned with the rigid links connecting from the top of this particular element to the soffit level of the girder. Also, the node local axis is used at each and every node location, so that in case if you want the local displacement, that can also be checked from the results tab. There's a self-weight which is assigned considering the type as dead load, and it is assigned with this particular self-weight command. So that's all actually we have done through this particular MCT as well. So one can work with this particular MCT. So yeah, there is a question regarding is it possible to model the superstructure according to one-way cross slope in MIDAS Linux? There is actually then what we can do instead of that, we can actually create the cross section considering that particular transverse slope. So right now, whatever the cross section we have modeled, this is actually considering this particular top slab as a straight. But in case, let's say you have a super elevation, okay, so that transverse slope can be defined in terms of the cross section definition, and then it will constrain automatically into the geometry. So that's actually the part of the section definition. Okay, so I hope this answered your question. Next, now coming to this particular substructure modeling. So now I'll go to the plugin, and here I'll go to the flared pier. Actually, it will generate the pier cap and pier both. So I'll go to the marketplace, and I'll select here the flared pier. Okay. So we can expect that okay, there will maybe separate plugin for the portals and so on. I will run this particular flared pier. Okay, so in this particular flared pier creator, I will specify the parameters related to the pier and the pier cap. Okay, So here now, if I talk about the peers, so the units, make sure that in the backend it should be in meter. So first is the, let's say I select here the groups. Now these groups will be generated by its own. So first is, let's say, the peer group, and here it will be, let's say, the peer boundary condition. That's the peer group. Then we have the peer start node. So either you can actually click on auto, so automatically it will take that particular node number. So you can see the node number here. So that's the starting node, because it will be 67 and 60, 66 and 67. So we have the 68, which will be at the center of this particular two nodes. Okay, and then the reference nodes. So I can select here. So there is a selection option available now in this particular option. So I can select 66 and 67. Okay, then the sections. So here I will assign, let's say, for this is for peer, so it is a column. For cap bottom, so this is a cap bottom. This is for cap top. But material I'll consider, let's say, the single material for everything. Okay, so you may have actually the substructure and superstructure material separately that you can specify. Then length, let's I'll consider here 10 meter in length. Let's say this is 1 meter and this is 0.5. Okay, so you can actually check this particular data before the geometry generate. So there is actually option for validation check. So the structure group, boundary group, and these are again the complete actually the list of all the parameters which is going to actually generate. So once you click on create, so it starts generating this particular geometry. So you can just turn on the hidden view and you can cross check whether the created geometry created as per our requirement or not. Now secondly, I'll again click on the auto here, or we can specify again this particular two nodes in between. So 65 and 64, and it will start with now 81. So again click on create. So just check the data and then click on create. So that's how these particular plugins will be actually worked for such type of geometries. Okay. Next one, regarding the, let's say, the foundation. Suppose we'll be now discuss about the foundation part. So again, from the marketplace, I will go to the group piles. So again, in this particular group piles, I will run. So this create the pile cap and the piles. Okay. Okay. So for this, we already actually created the material property and the section definition, right? So just we'll select the groups. So here I'm interested for the pile. So as I said, it is actually generating at this particular locations. So pile boundary group will be pile group. Material, let's say I'll consider this particular second material. Pile section will be pile. Uh, it will again take as it is. So if you want the pile cap to be created, so you need to turn on that one, and based on that, it will specify these particular sections. So this is for pile cap. Now we can specify, or you can click on this auto, okay, whichever actually it is requirement. And let's say I will start with 1001, okay, or you can basically actually either there's a user defined node definition, or you can just click on auto. Here I'm considering 3 by 3 of piles configuration with a spacing of, let's say, we can consider 3 by 3 with offset edges as 1.5 meter from that edge. Length will be in the, again, the this is actually in the diameter, which is 1.2 meter. This pile will be considered diameter 1 meter, and pile length is 15, and pile cap height is 2.5. So click on create, and then after confirmation, oh sorry, we need to actually select the node and then click on create and create. Okay, I think the nodes are already selected in backend. Sorry. There was already actually the few multiple nodes were created. So just click on the single node from where you are interested to generate this particular file groups. Okay. So once it is completed, right, now select the node at this side. Make sure that you are selecting one node at a time because 68 was already created. Now 81, and then create this one. Sorry, this was actually, we start with 2001 auto and then create. So that's how we can actually work for n number of these particular plugins within a same file for generating our required parameters. So the close it. Okay, so that's the idea about these particular plugins. Okay. Okay, so if you have any questions related to this, so we can take up the now queries. So let me just take you to the presentation now. Okay, so that's about actually these particular plugins. So I just want to summarize like the main actually the idea about or the benefits of this particular API plugins are customization. So as I said, it's not actually built for one type of component only, but the plugins can be generated for n number of components as well and for n number of functionalities. Automations, because as I said again, like we can actually automate the process to reduce our time and to reduce the repetition of the task. Integration, so there are plugins which can be even copy pasted from the Excel as well, so that again you can integrate with the Excel as well. The enhanced analysis, which is actually the capability of the MIDAS CLIVIL NX, and whatever actually this particular plugins we have seen, they're very user friendly. You don't need to use any like reference for what type of the data required for one particular geometry, so that is not necessary. So it's very user friendly. So that's from my side. Let me just take you to the our portal. Okay. So so if you have any questions, please feel free to ask uh, at the end. So here, this is actually our newly launched website, and either for putting the queries related to your modeling part or while working the software, you can actually use this. So we have the newly generated this particular website, that is a support.midasuser.com. Earlier it was global support.midasuser.com. Now this is actually the all-in-one website, because as you can see in this particular platform, we have actually the product related functionalities. There are resources, support. It will take you to the our portal for mentioning your queries and all, then the services and all, and then the academy portal as well. So if you go to the resources, we have again the tutorials and the API manual. Okay, so when we are talking about this particular plugins, so it is mentioned here about how to actually use these particular plugins, and these are actually the different plugins uh, now it is available. Okay, so this is regarding again the different plugins available, and ongoing plugins are also mentioned here. In case if somebody is interested to generate how these particular plugins can be created. So actually yeah, actually this customizing this particular plugins, there is again we can actually go to the another site, so that will share you so it is mentioned about how we can generate this particular plugins. Okay, so mainly this is actually shown by the how we can actually connect or create this particular plugin through the Python to create the nodes and elements and so on. I think it is okay. Yeah, so this is about the JSON manual which we are talking about, which is required for generating this particular API functionality. Okay, so thank you for attending the today's session, and I hope this is very helpful. So our next session, we will be discussing about the VBA, that is actually how the Excel will be compatible with the MIDAS Civil Linux and how the results can be extracted through the Excel for report generations and as well as for the other parameters. Okay. So let's take some of the questions which are already actually posted on the chat box. And if you have any questions, kindly post them into the online chat. So we'll definitely take them now. Okay. So there was a question. Okay, first question is regarding the pile cap will directly get the aligned as per the superstructure alignment. Okay. Here actually, as I said, the nodes which we have created, I just take you to the software. Okay. So if you check this particular nodes, we have already actually created this particular node. So if you remember, we have used the MCT command shell, and in that particular MCT command shell, let me just display these nodes. So these nodes are already we have created. So by using the vector command or by by our geometrical modeling, setting the UCS here and then copying that particular nodes. So once we create this particular node, now the plugin is generating the node between these two particular nodes. Okay, and through this node, it is generating this particular substructure. So that is how actually this particular the peer is working. Okay, so for piles and pile caps, is it create also the rigid links between the pile cap? Okay, let me actually take you to again that particular MCT, because so while MCT explanation I have mentioned about, like, we have created the nodes through this MCT earlier before we actually start our plugin for the substructure. So plugin is generating the line element for this particular substructure, which is a flared pier, that is a pile cap, sorry, pier cap, and the pier. Okay, whatever before that, it is already created the nodes below that particular box girder. It is also aligned that using the node local axis. Then it is constrained that the superstructure is assigned with this particular end supports. It is the bearings are modeled with the elastic link, and that particular bearings with the superstructures are connected with the rigid links. So they are actually already created with this particular MCT file. And after that, so our flared pair was generated from this particular node, 82 node number onwards. I think most of the actually questions are related to that one only, but in between, to reduce our time, I have created this MCT. For piles and pile caps, is it create also the rigid link between the, yes, that is actually program has created automatically. So this group piles has created by its own the rigid link. I just uncheck this particular hidden view, and I just display all these particular boundaries. Okay, so if you check this rigid link and the supports beneath this is already created from sorry, this is created from the plugin. So the plugin is creating the cap about this. So this is a cap element. You can see this particular section and pile cap section. So this pile cap section is created element as well as element is created from the plugin, rigid link, and the piles with the a number of division and the support below that. So it's assuming it as an end bearing, but again there is plugin coming with the soil spring application as well. So that we can expect in the future. Okay, just click. Right. Next is can we record the process of steps like a macro and create plugins for the same? Okay. How to create this particular plugins? We are actually bringing some short videos for that. But again, that definitely help for those who knows already some actually the basic idea about the programming. Okay. So, but we are actually bringing them how to create this particular plugins so that the users they can create their own plugins. So we'll share that one as well, the different shortcuts and how to create that one. So MIDAS Civil Linux license different from the, I think this will be actually the sales question. So I would like to mention like you can actually connect to with our the salesperson to know about this particular details. What is the size of the created after analysis completes? In current MIDAS Civil, the file size generates after the analysis in multiple GBs. Have you worked on this file? Okay, yeah. So there is a question regarding the analysis file size. So here, when you are working with the MIDAS Civil Linux, MIDAS Civil Linux is generating the file type into MCBZ. So just a MIDAS Civil file is MCB, and if you run the complete file, file, so there will be n number of files will be generated within a folder. So here the MIDAS Civil Linux is generating that whole thing into a zip format, so that when you are sharing the file to the other user, or even the space which is actually utilizing from the particular file with that particular drive, so it can be get reduced. So definitely because of that particular compressing that particular folder, your file size, the whole file size will be reduced. Is there any option to interface the Revit and MIDAS models? We have actually the option for connecting the MIDAS Civil with the Revit. So whenever you are installing the MIDAS products, so all MIDAS products are getting linked with the Revit structures as well. So you need to uh, install this particular add-in, so which is actually the MIDAS link for Revit structures. So make sure that both the version of MIDAS Civil or MIDAS Civil Linux and the Revit are same, and through that you can interchange the model as per your requirement. So how to the manual flare without plugin? How to manual model flare sections? See, the flare now actually the structure which is created is basically a tapered section. Now, if you want, there are different ways. Either we can create just a single line element. Through that, you can have the multiple sections in the tapered part. So here, if you check the column top and column bottom, so they are of a different properties. Basically, they are the tapered sections. Okay, so that is what actually it is assigned here. If I turn on the hidden view, so you can see this is actually the variation. So here there is a one variation here, another variation here. So that's the column top and this is the column bottom. Okay. So either you can model in this way, or we can have a horizontal member, and then that can be defined for the horizontally divided member into a different number of parts. Okay. What doesn't have the solver, it makes over performances. Okay, regarding actually the license, I would like to suggest you can actually mail to one of the actually the email ID which will mention at the end. So that's the Karthik, who will be actually the contact person. So to whom you can actually contact related to your license, as well as related to the any sales part. In fact, those who are asking for the trial version, so yes, we will actually provide you the trial version of this particular software. So you can try and taking the reference of your tutorials available on our official site. Okay, so if you check the again the top view of this particular structure, the here actually the plugin is generating this particular structure considering this particular first angle, which is actually at this particular location. From that, it is taking this particular alignment of the footing or even the substructure as well. So that is taken care by the program, because this structure is already made from this way. So when you are selecting this node, it is taking the with reference to that particular local axis, because the program is already generating the local axis for each and every elements. Let me check this. So it is for the superstructure as well as for this particular member. It is already aligning each and every member based on this one. So that's why it will take that particular reference axis. Okay, so we'll share you the recording of this particular webinar to all the attendees. Okay. Right now, actually, this plugin will work for the line modeling only. So there is a question regarding the candidates tendon profile in the plugin. Okay. Actually, there is actually plugin for not for the tendon profile. Let me just show you that particular model. Basically, that there is a one plugin called the tendon profile that is not for building the tendon, but it is for changing this particular reference axis. Uh, एक second. Instead of actually just to demonstrate that, I'll explain that one. So basically, we have actually one straight box girder, and in that particular straight box girder, we already have some tendon profiles, considering a reference as element. Now, when I change this particular geometry as a in curvature, let's say, so definitely my alignment of this particular tendon need to be changed. And plus, whenever we are assigning the tendons in the curved alignments, so it is always recommended to use the either straight or curved type of reference axis, which is available in the tendon profile option. So that's why this particular tendon profile converter option will convert that particular reference axis, and it will calculate all the tendon coordinates with reference to the global coordinate system. So as you can see, all the tendon profiles which are getting updated, and once you update it, you can see now the tendon profiles from your definitions. So if you check now, these are the newly created tendon profiles, and if you check the property related to this particular tendon profile, now the reference axis now got changed. Okay. Okay. So you may actually put some request as per which plugins you are expecting in future. So definitely we'll try to recollect them, and we'll try to develop them. But again, as I said, once the user understand which plugins they are necessary, so yes, they can actually create them their own as well. So we are actually bringing how to create these particular plugins and how they can develop and put it in this particular marketplace. So that will actually cover. Okay. So I think we have answered the most of the questions. Yeah. So so still, if you have any questions, so you may contact either our help desk, or you can contact our representative, that is a Karthik, okay, related to any sales part as well as for the trial versions. So thank you everyone for your time and to attend this particular session. So let's see you in the next session. So thank you and have a nice day.